This tutorial is going to deal with how to do an image construction for a diverging lens. So I've drawn my principal axis, I've drawn my lens. Notice that this is a lens that's thinner in the center. It's a diverging type lens. And I have made my primary and secondary, or principal and secondary focal points. Note that for the diverging lens, the principal focal point is on the left side instead of the right side. The secondary focal point is on the right side and the left side instead of the left side. They've switched positions. That's going to make drawing our rays just a little more interesting. So let's start with the parallel ray. So the parallel ray, we said, starts at the tip of my object and goes parallel to the principal axis until it hits my lens. Then it refracts through the principal focal point. Well, it's clearly not going to refract backward. It's not going to come back. It's not going to refract and come back here. So what do? Well, I draw it as if it had done that. So I'm just going to start at my principal focal point, and draw my ray. So now with this ray, I have the direction of the light is following those arrows, and on the left side here, that is an extrapolation. So let me put some dashes on that extrapolation so we can tell the difference in the actual light. The real light is the magenta line. The projected is the dashed. Now let us go to the focal ray. So for the focal ray, it is going to start at the secondary focal point and go through my object, or go from my object to the secondary focal point. Well, I can draw a line that goes from my object to the secondary focal point, and I'm just going to, well, I'll stop it right there. But the thing is, once it gets to the lens, it's not going to keep going. It's going to, the focal ray comes out parallel. So it's actually going to come out parallel like that. But if it's doing that, then I actually have to look at my projection backward. And so here I have my projection coming back. And just like before, I'd better do something so we can tell what's a projection and what's an actual ray. Now, this one here, the last part I did, no light did that, no projection of the light. That was if I had gone straight, it would have hit the secondary focal point. But it refracted. And so the actual light went like this, came out like that. Now we can see these two, the parallel ray and the focal ray, the light is never going to meet. But projecting backward, I have a place where they're going to meet. Well, we need to do the third ray just for verification. So the third ray, thankfully, is simple. The third ray starts at the tip of the object, goes through the vertex, and keeps going in a straight line. This one here, I don't have to worry about any projections. That's what it does. And so now if I look at this, there is a location where all three of these rays meet. And that location where all three of the rays meet is right there. So there is my image. Now, if you look at this image, once again, we want to judge that. Is that upright or inverted? It's upright because the arrow is pointing the same direction as the arrow was from my object. Is it real or virtual? Because it's the projections rather than the actual refracted rays that meet, then this is a virtual image, and it was diminished in size. And again, I point out that upright and virtual go together. Now I've done 2 images for the other lens, for the converging lens, or 2 constructions. I'm only going to do 1 construction for the diverging lens for a very simple reason. You are always going to be farther away than 1 focal length from the secondary focal point if you're using a diverging lens. Hence, you're always going to get this behavior. It doesn't matter where your object is. If you have a diverging lens, you're going to have an upright, virtual, diminished image. And so there's the ray construction for a diverging lens. And that ends this tutorial.